Hello everyone, this is Lab9 video of Team Linabell for EE542. In this video, we will demonstrate the Android-based IoT interactions with Node-RED, ThinkBoard, and AWS IoT. The team members are Yixin Wu, Donghao Zhao, and Boyang Xiao. The lab mainly consists of these 7 parts. Hi, this is Donghao. In this part, I would like to demonstrate to you how did we set up all the environments, which is the first 6 parts of the lab. First, we need to install the Termux on the Android phone. To do that, we can't just follow the instruction because according to the information in this website, the Termux in Google Play Store is deprecated. So if we install Termux through Google Play Store, we can't use Termux sensor command. Thus, we need to go to these two websites to download Termux and Termux API, which is these two websites, Termux and Termux API, and install the packages manually. So then after that, we need to proceed with these commands to set up SSH. Install Termux API and create a new user for login. Next, we can use SSH to connect to the Android phone as I am showing now. And as you can see by typing this command and enter the password, then bingo, as you can see, the connection has been established. Next, we want to obtain the sensor data from the phone. The Termux sensor command will do the labor. If we type Termux sensor-l command, we will see the command list available for this phone. Then the Termux sensor-a command will show all the sensor data in the terminal continuously. If we just want one batch of all the data, then we append -n space 1 to the previous command. And we can also explore the option for the Termux sensor command by just typing it. Next, I am interested in the light sensor here. So we use this command, Termux sensor -s, and we copy the name of the sensor and paste it. Then as you can see, we can use this command to show the data only from this light sensor continuously. So until now, we successfully obtained data by Termux sensor API. Now we go to the AWS IoT core to create a new thing device. First, we created a new policy named Lab9, and we allow all sorts of IoT policy actions and policy resources. Second, we created a new IoT thing named Lab9 Thing1, as you can see here. One thing I need to mention in the slide is that we can only download the key files for the certificate while we are creating it. So we also downloaded the public key, private key, and root CA certificates before. In the next step, we install the Node-RED following the instruction in this website, which is this website, and we can access Node-RED from the 1880 port from the browser, as you can see here. Then we created this flowchart. Basically, it listens to the port 1880 for the sensor data sent from the Android phone. Then it extracts the data, the sensor data, which is the number at this node, then format it and send it to the AWS through HTTP request. To send the data to AWS, we need to give the right URL here. The URL, which is the endpoint, which consists of the endpoint and the topic. The endpoint can be found in the settings tab of the IoT score, which is here. As you can see, the topic that we customized is topic Lab9. Also, we need to click the pencil icon here to upload the certificate and the key file that we just downloaded. After that, we install the Node-RED on the Android phone by these commands and created this flowchart on the Node-RED. Basically, it uses Termax Sensor API to read the sensor data and send it to the Node-RED on PC. So in the HTTP request node, we put the IP of the PC and the port number of Node-RED in here. After the deployment of the Node-RED flowchart on PC and Android phone, we can see from the console on PC that the sensor data has been successfully sent to AWS. We can also prove this by subscribing the same topic on AWS IoT core, as you can see here. It is updating. Another way to send data from Android phone to PC is to use the curl command. As you can see here, we wrote this script. Running this script will also send data to PC. As you can see here, and we can prove this by looking at the terminal on the PC end. So it is updating. Next, we installed the things board on an AWS instance following the instructions in this website and access the things board from the browser and log in. We then modify the flowchart on PC to send the data to the device that we created on the things board through the access token of this light sensor device. And we put this light access token in here. And then we can visualize the data on the dashboard that we created. As you can see here, the data is updating. Finally, we created an S3 bucket and created a new rule to redirect the data from the instance to S3 bucket. As you can see here, the files are stored in the S3 bucket, and the content of these files are these. So the sensor data has been successfully stored in the S3 bucket.
So in the very next step, we will read the sensor data from our Android phone, and we get the data from the Node-RED in our PC, and we change the format of all the data and the time to the human readable format, and we send it to our AWS S3 buckets. And the first thing we will change the change a flow. We'll create a flow for our phone, and you can see that this is our whole flow for our Node-RED. And you can see that we put a trigger first, and we go through 6 sensors. They are the light sensor, the accelerator, and all of them the sensors. We read the sensors from our phone, and we get the data from our sensor. We put it in our JSON file, and we send it to the our Node-RED. And in this side, we can see that we write a function to change the format of all the data. We add the date, the year, the month, and the day, and also the hour, minute, and second to our data, and put it all in a string. And we put this whole string in our msg.payload attribute, and then we send it to our AWS bucket. And you can see that from our AWS side. Wait a minute. Yeah, we got all of the data saved in our S3 buckets. And if we download all of the data, we can see that the format of the data is saved like this way. We got the date, the time, the timestamp, our sensor name, and our sensor data is all saved in this file in our S3 bucket. So and then in our flow, we read all 6 sensors, and we send them one by one, and then we also send all of the data to our dashboard, the things board, the dashboard. And you can see that we create all of the data in a chart, and you can see that all of the data are updated. And if we change the phone's light or gravity, and you can see that the data will change. Yeah, you can see that there are some change on our dashboard, because I just put our change the light, the gravity of our phone, and also the rotation, the accelerator. And you can see that all of the data are changed in our phone.
As for step 3, the first thing we need to do is to create a table, and the name is Lab9. And after creation, we need to also create lambda functions. And here we need to configure its permission, its access. It's access to the database. In the access management tab, the roles, we need to include this full access into the policies. And then we will back to the code part. The variable event is the JSON we received from the Node-RED, and we can create the event for the login, and then we can put the item to the table Lab9 according to its UID, which is the timestamp and the name and the date and the phone ID to distinguish different phones. And here we can check the log files at the CloudWatch management. As we can see, the Lambda function is triggered by every IoT input, and this is the input. This is the output of the JSON file, and the whole function is triggered by the AWS IoT. And we can take a look at the items in the Lab9. This is the whole database, the table we got from the node RAD.
And in the last part, we will answer this question: how would you pass the sensor input to the ML model to train it and make the prediction on continuous streaming data, and how would the ML predicted output flow to a mobile phone to pop up some message or trigger an event? So I want to elaborate this question. Use this figure which contains six steps. So in the first steps is the data collection. We will use the Android phone sensor to collect their data. We send the data up to the AWS DynamoDB, and we save their data to a table with timestamps, the phone IDs, the sensor data, and so on. And this is what we did in this Lab9. And the second step is the S3 file storage. So we save the DynamoDB table to CSV files, and we store all the CSV files in the S3 buckets on AWS. And the third step is the machine learning model training on the clusters. So this is like what we did in Lab 7. We opened the cluster on AWS, and we configure it to run PySpark. And we use the machine learning models predefined in the PySpark libraries. And then we read the CSV data files from the S3 buckets and train the machine learning models with the data. And the fourth step is that when we train our machine learning model, we save the trained model on our S3 buckets. And if some more data come from our Android phone, we can use the trained model and the newly imported data to predict. And the fifth step is that we save the prediction results back to the S3 buckets for further use. And the last step is that we send back the result to our phone. So we can use the AWS SMS service to send our prediction results back to our phones or over the SMS messages. So in this way, we can do the whole process with the trained model and the prediction results and send back to our phone, and we can finish the whole process. And that'll be all for our presentation of Lab9. Thanks for watching, and see you on the next lab. Bye bye.